welcome back, everybody. So for now, I want to introduce Sohan Maheshwar from authZ, and he's going to talk about implementing authorization system within Google with Zanzibar.
Thank you. Hello, everyone. My name is Sohan Maheshwar. I work in a startup called authZ. I've been in the industry 16 years now, quite an old fart. And I'm based right here in Amsterdam, close enough to bike to the venue. So today I will talk to you a little bit about the problem of authorization. I will start with a quiz question, but I'm warning you, if you know the answer to this, you might reveal your age, and you're definitely not Gen Z. So be careful before answering it, but does anyone remember this tool? Okay, a Gen Z person just answered it. What is it, anyone? For the Yeah, exactly. Yeah. So this was called Google Plus, or also Google Circles, and this was an attempt by Google, to build a social network. And this was maybe early 2010s. People used it a lot for a few months, right? No one used it after that. And the idea was simple. Unlike Facebook or LinkedIn, where everyone sees everything, you could have circles of people, right? So you could have university friends and family, and you could share only certain things with them. Now, the story goes that to build this, Google actually re-architected how they did authorization internally. And something came out of that. Because even now, if you've ever sent a link of a Google Doc in Gmail like this, you might see this pop up, right, saying, have you shared this with the person you're sending it to? Which, if you think about it, it's actually magic. Because these are two different apps altogether. So there is a centralized authorization check that's happening between these two apps. So this basically is possible because of Google's internal authorization system, which is what I'm here to talk to you today. I'm going to set a little context, though, because in our industry, we conflate the word auth with actually two different things, right? Authentication is identity, who you are. So if you've ever used LDAP or Okta or anything like that, that is authentication. Authorization is what comes after that. What can you do? What permissions you have? And that's what I'm focusing on. And in the past, we have done access control lists. This is way back in the day. So say you had a document, document 1. You had a full list of all the people who could read that document. And then you had another list of all the people who could write to that document. Not very scalable. So things changed a little and evolved to role-based access control, or ReBAC, where you have a role, and I'm sure you have this internally as well, where you have a role like software engineer. And all software engineers can do a certain thing. Someone's tagged to sales. All salespeople can do a certain thing. Also can get complicated at scale, because what if a salesperson wants to check in code? You have to create a new role for that. The evolution of that was attribute-based access control, where everything has a bunch of attributes, and at the point of decision, all these attributes are checked. So say I want access to a file, they check my email ID, location, IP address, a bunch of other things, and you get a yes or a no. Now again, this can get complicated at scale, and we're talking about the scale for Google, right? Billions of users across the world. So they basically thought of a different way to do access control. And we know all of this because in 2019, they released a white paper called Google Zanzibar. And it's a great paper to read. So if things like distributed systems excite you, like it does for me, check it out. 14 pages written in plain English. And they describe exactly how their authorization system works. And this authorization system is also confusingly titled Zanzibar. And in it, they say back in 2019, they could do more than 10 million queries per second. I'm sure that number's increased by now. And this popularized this concept of ReBAC, or relationship-based access control. So what is ReBAC? The idea is, instead of a role or an attribute, it's to humanize how the different things like objects work with each other and draw relationships between them. So say you have a document. That document resides in a folder. So there is a relationship between the document and the folder, in the sense that it exists in that folder. In the same way, you have a user who has access or is a viewer of the folder. So there's a relationship there. And by transitive properties, the user has a relationship to the document. And this is the fundamental idea behind ReBAC, or relationship-based access control. So what can you draw relationships in between? In Google, you typically do a user. So if any of you has a Google ID, I'm guessing yes, you have what's called a Gaia ID. It's a 12-digit number. So one has to be a user, and the other is any object. And this object could be anything, a YouTube video, a Google photo, Google Doc, Gmail, anything. And the relationships could be things like is a member of a group, or is an editor of a document, or uploader of a video. And this gives flexibility to Google. So say they release a new product tomorrow, they can use the same system where they define a new relationship. So you have these users, you have objects, you have relationships in between them. How do you tell a computer or a system that these exist? So in the white paper, they have what they call a relationship tuple, or a relation tuple, which is the format by which you tell a system that this is a relationship. So here's how you read it, and if this is confusing, speak to Google. You start at the hashtag and what's on the right. So you go user number 3 is an owner of document 123. Yeah? So say user 3 creates a new document and calls it document 123. This is what is being written into the system. And this is flexible because you can have objects that also relate to other objects, and objects can also relate to other objects' relations. So again, here, we go with the group security is a member of the group engineering. Now think of a time a reorganization has happened at your workspace. Suddenly, you're moved to a new business unit, and that involves so much of a change in permissions and access control and LDAP and all of that. But in this new system, it's about just writing a new relationship. You would just write group security is member of group DevOps. And you would write that into a system, and everything would fall into place. So what are we doing with all of this? We have these users and objects and relations. What do we do with it? The idea is to build a directed acyclic graph from all of these, where every user, object, and relation are nodes on the graph. So I'm going to use this example of Google Docs for the next few slides, where I say there is a document, and you have few readers, and they can have certain relationships. So we have Fred and Kim, who are readers, and we have Jill, who is a writer of this document. The key here is to see this dotted line in between reader and writer, which indicates that anyone who can write to a document can also read that document, just like in Google Docs. And again, this gives a lot of flexibility for a company like Google, because say there's a new requirement to add an organization to this structure. It's just about adding a new relationship or a new node in the graph. So in this case, you have an organization called Acme Inc. You have an admin, and you add admins. And there's a dotted line which says anyone who's an admin can write to the document. And we already know all people who can write to a document can also read the document. So this is the idea. So we have this graph, and you want to check for permission. Right? Say someone sends you a Google Doc, and sometimes you get the access denied. So what's actually happening behind the scenes? Well, the idea is if there is a one-way path from the document to the user via the permission, then there is access or not. So say a check comes in. Let's check if Jill can read some document. Right? So Jill is here, reader is here, and there's some document here. If you can find a path from some document to Jill that is unidirectional, that means there is permission. So in this case, there is. You can go from some document to reader to writer to Jill, so that means Jill does have read permissions. Let's take another example. Can Fred write to this document? And if you see, there's no way to go from some document to Fred via writer in a unidirectional way. So Fred does not have permission to write to this document. Again, if you've ever seen the access denied to a Google Doc, this is the sort of check that's happening behind the scene. Now, the question I get asked when I explain all of this is, sure, so on, all of this is well and good. Clearly, this does not scale to the system of Google, right? Billions of users and all of that. Well, it actually does. And again, we know how it does because it's listed in this white paper. And I feel that is an entire talk in itself, but I'll give you the shortened version. They aggressively break all of these things into subproblems, and then they try and cache as much as possible. What does that mean? Now, this, again, is our example, right? So how do you break this into subproblems? If you look at it, this actually is a union of 3 problems. The first one is Jill a reader of a document, right? Direct reader, and the answer is, well, no. The second one is Jill is a writer, and we know writers can read, so the answer is yes. And the third subproblem is Jill an admin of this organization? So there is an aggressive breaking down of this into subproblems. And what the system does is when it sees that, OK, we have a correct answer for the question that came in, it stops doing the checks below it. Yeah? So you're increasing in speed. Remember this one slide, though, because I'm coming back to this exact point later on. And now once this is done, you can actually cache results of this. Because if a query comes in saying, is Fred a reader, we have already traversed this. We have already gone from some document to reader to Fred to check for Jill. So that result has already been calculated. So you don't have to calculate it again. So that is actually cached. The next question I get when I say this is, hey, hold on. Permissions change all the time. Suddenly, someone can remove me from a document. And if you're caching everything, how do you know you're getting the latest version? Which is a great question if you thought about it. And for that, the Zanzibar paper actually introduced something that they called the new enemy problem. Now, today's topic is building resilience, and this is a very important thing to know about. Because this happens a lot in security breaches, where, let's say at T1, we have Lex, who can access secret plans, and Kara removes Lex from this document. So Lex shouldn't be able to access this document. Now, Kara adds new secrets, right? And now Lex definitely should not be able to access this document, because there's something in it that he shouldn't be seeing. But immediately after that, Lex attempts to read this document, and unfortunately, chaos can ensue, because he still has access. It's not been updated. So how do you solve a problem like this at the scale of Google? The Zanzibar white paper introduces this concept called a Zuki, which probably stands for Zanzibar cookie, but they don't mention it, so don't know, where every time a change is made, a timestamp or a token is issued, right? And it's called a Zuki. And this token is passed on with every change. So when Kara is actually checking at T4, or anyone's checking immediately after T2, you can say, give me the latest update after time T2. And that timestamp will tell you about when the change was made. So this way, Google can also achieve consistency based on that Z token, right? So in terms of a cache, if for you having the latest is important, you can say, give me the latest update based on this Zuki. And that way, it won't go to the cache, but it will get you the latest. You can also say, you know what? I don't need the latest. Give me the fastest possible one, where it can get from the cache, where it could be a stale permission. But either way, that's your use case. So talking about cache, this is a line from the Zanzibar white paper, which says, we found the handling of hotspots to be the most critical frontier in our pursuit of low latency and high availability. Essentially, a hotspot is when many people are trying to access one certain thing. Say a YouTube video has gone viral, or someone shared a document with an entire organization. Everyone's clicking on it. Again, this is an entire talk in itself, because there's a lot of distributed caching that happens when Zanzibar is installed. But the one thing which I thought was super interesting is when you have really hotspots, right? Like, say the whole world is trying to access or watch a YouTube video or something like that. So in that case, they actually do full reads for object control lists. So remember when I said this will be canceled if we find a result? Well, the Zanzibar system realizes that, OK, this is a hotspot, so let's actually do the entire graph. And then if other people try and access it, you actually get cached results because they have delayed this cancellation of the subchecks, which again is very, very smart design. The thing is, this could use a little more memory and bandwidth because you're making more checks. But for all the millions of people who are accessing this, it's faster. So your latency reduces, and subsequent reads are improved. From the white paper, they actually say that because of all of these techniques, they prevent 500,000 internal RPCs, or calls, per second from actually creating these hotspots. So that's really the scale we're talking about. 500,000 calls per second is prevented by this handling of hotspots. Now, this paper was launched in 2019, and it made waves in the IAM space, identity and access management space, because everyone was like, wow, this is how a company like Google does it. In fact, companies such as Airbnb and Carta, they restructured their entire IAM teams and built it around Zanzibar systems, so they still run on that. So at the same time, there were open source versions of Zanzibar as well. And this is a famous lineage of a Google product that is then open sourced and everyone else uses it. The most famous example being, can anyone guess? It was mentioned in the talk before this. Yeah, it's Kubernetes. So Kubernetes was a Google project called Borg, which they used internally to orchestrate their systems. And then Google decided to open source it, and now the whole world uses it. I've even heard that trains running in Europe run Kubernetes clusters that are collecting and sending out data. That's how famous it is. So in that lineage, from this white paper, there were a bunch of open source projects that tried to make or replicate the Zanzibar system for the outside world. These are the 4 famous ones right now: SpiceDB, Ori, OpenFGA, one there, and Permify. I'll show you like a quick 2-minute demo on SpiceDB. It's an open source product that our company helps maintain, but it has contributions from Google, GitHub, Netflix, Reddit, and so on, completely open source. And the one metric that matters to us as developers is GitHub stars. So we have 6,000 GitHub stars and counting, hopefully a few more after today. I can give you a small demo based on the things I just told you about how you have a schema, relationships, and permission check. And I can just show it to you in the browser itself. The first step, typically, in any Zanzibar-like system is to create what's called a schema. Now, a schema models your use case. So again, if I'm creating something like Google Docs, I define the users and the objects in there. And then I define the relation between the user and the object. So a user can be a writer, a user can be a reader. If you want, you can say, I can add commenter as well, saying, a user can be a commenter of a sheet. And the idea behind this is to take any use case you have and model it based on schema. It could be something in the finance world, in the AI world, anything. You define the users and the objects and the relationships between them. And for each relation, you have permissions. So writers can edit a file. The people who can view a file are both readers and writers. Again, I can add a new permission for, say, comment, which is saying writer plus commenter. And then commenters also should be able to view files. So any use case that you have can be modeled using schema. Once you have the schema, it's about writing the relationships between the users and the objects. So typically, you would do this in code. This is just a demo. But here's where I'm writing the relation tuples that I told you earlier. Right? So I say doc1, there's a writer named Tom. Doc2, there's a reader named Fred. Suppose someone creates a document called document3. Right? So I will say writer at user equal to me. There you go. So in the code, when a new document is created by me, this sort of relation is written into the system. And lastly, it's about permission checks. You can have all sorts of permission checks. You can say something like permission check. I want to see if I can access a certain document, right? So I'll say doc1, view, user, right? And it's false, because I can access only document 3 right now. So let's see if that works. We can add the explain flag as well. And it says true. This is how the check is actually done in the graph that I told you about. There's document 3 reader, nope. Document 3 writer, yes. And this essentially is what the system graph looks like. Remember, I showed you the directed acyclic graph. Well, this is a visualization of how that looks. The interesting thing is you can also do lookups. So it's not just permission checks. So you can do something like a lookup to say, give me all the documents that Fred has access to. Or give me all the people who can access document 1. So we will say document view user equal to Tom. Yeah. So we can see Tom can access document 1 and 2 here, and the lookup returns the documents that Tom can access. And again, you would typically do this in code, but I'm just using a CLI tool and using a version of SpiceDB running in my browser. So this made, like I said, it made all sorts of waves. And the idea is Zanzibar-like systems shine when you need scale and when you need low latency and high availability, especially when you have lots of hierarchical data lying around. Now, this could be things like documents, but also AI use cases like RAG pipelines, where you have millions of documents and users who have relationships with those documents that could change at any point of time. And it has to be reflected in a global system. In fact, if anyone here has used ChatGPT, which I'm guessing is all of us, you'll see there's a new product that they have called ChatGPT connectors, where you can connect your Google Drive, Dropbox, and SharePoint, and then ask questions based on it. So you can be like, give me data from this document. And this product, OpenAI, uses SpiceDB and a Zanzibar-like system for this. So they are actually able to process 37 billion documents across 5 million users because they use a Zanzibar-like system, because that's what it is really meant for. High number of relationships, high number of documents, but low latency and scale. Why am I telling you all this? Why is this so important? The theme of today's conference is building resiliency, and most people here might have heard of OWASP. Yeah, everyone? Yeah? Open Worldwide Application Security Project. It's a foundation that talks about things like risks to web apps and cybersecurity. And every few years or so, they make a list of risks to web apps, risks to LLMs, and so on. And number 1 in that list currently is broken access control, because we've seen a large number of breaches thanks to things like the new enemy problem and just access control not being fixed. So, maybe your use case could use something like a Zanzibar-like method, which is why I think it's important to talk about it. And with a bunch of AI use cases and RAG pipelines and AI agents, I think access becomes that much more important. So it's something to think about as we move into this age of AI. Anyway, for next steps, do check out the OWASP top 10 list. That's always a good place to start with security. Again, if you like reading things like distributed systems, the Zanzibar paper is great. It's online. There's an annotated version right there. And if you're a hands-on coder, and if you want to write code, SpiceDB is completely open source. Feel free to jump in, contribute to the project as well. I'm here to help if you need anything. And hope you learned something new today. Thank you very much.
Thank you very much for this talk. Are there any questions? Yes.
Hi. About this relationship, authorization by relationship, I was wondering, is it possible to apply some attributes to not just determine if the user is able to access certain document, but also access certain document with the additional attributes provided to the document provider, like Google Docs. For example, the user Sohan can only edit this document between 1 p.m. and 2 p.m., something like that.
Yeah, that's actually a very, very astute and great question, because the Zanzibar paper does not have support for that. Right? If you read the Zanzibar paper, you can't do dynamic things exactly like this. And then I'm going to give you SpiceDB's version, because we released SpiceDB, and Netflix was actually interested in using this, but they needed exactly this. So Netflix contributed to the open source product something called caveats, which is exactly like this, where you can add a caveat to a relationship saying, allow access only at either this time or something like that, which makes it a little dynamic. So short answer, SpiceDB does support it, and you can use it.
Nice. Any other questions? No, there.
Hello. As you mentioned, this technology, these principles shine like in big environments, like a lot of requests. Yeah. But I also see that the value of relationship-based concept, like for a small or medium-sized project. Is there a way that use some of these principles without the overkill of deploying like a big solution, like for example, like that? Like, what has been your experience? Thank you.
Yeah, absolutely, right? In the sense, many of our customers just straight up use the open source product, and they have deployed it in production in like small projects as well. The one basically area of complexity is it's not a drag and drop feature like a lot of security products. It fundamentally involves rethinking how you do authorization. So for instance, when you create a new document, you also have to create a relationship, which is like an additional API call, which is like a line of code, right? And in our experience, at least a smaller team, building a product, they don't necessarily have either the time or the bandwidth to re-architect that. But if you're thinking from first principles and writing code and saying, this is going to scale in 2 years, and it's going to get complex in 2 years, let me start now, absolutely you should go for it. So it works. And the way I see ReBAC is a superset of things like role-based access control and attribute-based access control as well, because you can model a role-based access control in ReBAC. So you can still have a role and things, but in the background, it's all graphs that is happening. Right? So it absolutely can work for a smaller project too.
Any other questions? No.
First of all, thank you for your presentation. Secondly, you showed the examples. Last one was about you looked up user, what he can access. How is it done? Is it a just reverse graph problem or something more fancy?
Pretty much, yeah. It's just a graph traversal, right? Let me go to a clearer graph. So, yeah, basically there are two things you can do. You can say, give me access to all the readers of some document, which would traverse a graph and then do this, right? And what I showed you was the other way around, like give me all the documents Fred can access, which does a reverse lookup. And in reality, this is a huge graph with like hundreds of documents. So you're traversing that graph and you're doing that. Yeah.
Yeah, maybe it was some kind of optimization caching layers in between, because it looks like a complex problem.
Yes, yes, absolutely. This is a very computationally expensive route, and this can get very complex if you have a folder in it, you have another folder, and then you have another folder, and then someone refers the first folder. So in the Google white paper, there's an entire section called the Leopard indexing system, which basically is, at a very high level, how they denormalize all this data. So think of a very large database, with hundreds of rows and columns. In a way, you're sort of flattening it out so that there's just like one long row for easy access, which is cached. And that's what it does. So that's the optimization that would happen for something that's computationally expensive.